Hello everyone, in this video I will be explaining on the introduction of transmission electron microscope. This transmission electron microscope is also an optical microscope which is used in the lab for diagnostic purposes. This transmission electron microscopy is a microscopy technique in which a beam of electrons is transmitted through a specimen to form an image. The specimen is most often an ultra-thin section, less than 100 nanometer thick, or a suspension on a grid. The transmission electron microscope is used to view thin specimens, tissue sections, molecules, etc., through which electrons can pass, generating an object projection image. The transmission electron microscope operates on the same basic principle as the light microscope but uses electrons instead of light. Because the wavelength of electrons is much smaller than that of light, the optimal resolution attainable for transmission electron microscope images is many order of magnitude better than that from a light microscope. Thus, transmission electron microscope can reveal the finest details of internal structures, in some cases as small as individual atoms. This transmission electron microscope is a type of electron microscope, where there are two types of electron microscopy: scanning electron microscope and transmission electron microscope. Here in this microscope, a high energy beam of electron is shown through a very thin sample, and the interactions between the electrons and the atoms can be used to observe features such as the crystal structures and features in the structures like dislocation and grain boundaries. Chemical analysis can also be performed. The beam of electrons from the electron gun is focused into a small, thin, coherent beam by the use of the condenser lens. This beam is restricted by the condenser aperture, which excludes high-angle electrons. The beam then strikes the specimen, and parts of it are transmitted depending upon the thickness and electron transparency of the specimen. This transmitted portion is focused by the objective lens into an image on phosphor screen or change-coupled device camera. Optical objective apertures can be used to enhance the contrast by blocking out high-angle diffracted electrons. The image then passes down the column through the intermediate and projector lenses is enlarged all the way. The image strikes the phosphor screen and light is generated, allowing the user to see the image. The darker areas of the image represent those areas of the sample that few electrons are transmitted through, while the lighter area of the image represents those areas of the sample that more electrons were transmitted through.